Today we will discuss about a qualitative description of a non-rigid rotator. In the previous class, we discussed about a rigid bond. Rigid bond means a short bond. As the distance between the two atoms or a molecule goes on increases, distance between two atoms or a molecules goes on increases, the bond will be weak or it is bended. Hence, this bond is known as non-rigid. If the short bond is there, then it is called as a rigid bond. If it is long, then it behaves as a non-rigid instead of a rigid. So, in the earlier class, we discussed about the energy, that is E is equals to H divided by 8 pi square I into J into H square divided by 8 pi square I J into J plus 1. We know that E is equals to H mu. Now we can calculate the mu here, that is mu is equals to E divided by H. The value of E is H square into J plus 1 divided by 8 pi square I into H as it is. So this is cancelled. The mu is equals to, that is frequency is equals to Hj into J plus 1 divided by 8 pi square I. As the value of J is nothing but a rotational quantum number. As the value of J is increases, the frequency is also increases. And the frequency of rotation is increases, then this bond is behaving like a non-rigid. Instead, it is a rigid. Call it as equation number 1. We can write mu is equals to Bj into J plus 1. So as the wave number of a rotational level of a rigid rotor, wave number is denoted by mu bar is equals to, instead of mu we are taking in terms of frequency, it is mu. In terms of wave number it is mu bar. So hence this can be written as mu Bj into J plus 1. Call it as equation number 2. Now the molecule is behaving like a non-rigid, hence this equation can be written as mu bar is equals to Bj into J plus 1 minus dj square into J plus 1 whole square. Call it as equation number 3. So this term is called as a centrifugal distortion, this d is called as a centrifugal distortion constant, because centrifugal means when the bond is increases, the molecules or atoms are behaving like or they are acting as a centrifugal force. So hence d is called as a centrifugal constant. Now the transition is taking place from J to J plus 1. So the energy, these are the energy levels. This is a J, and the transition is taking place from J to J plus 1. Hence the molecule is behaving like a non-rigid rotor is given by delta mu bar is equals to delta mu bar J plus 1. So the transition is taking place here to here. So that is the difference between J plus 1 and J is given by the delta mu bar is equals to delta mu bar J plus 1 minus delta mu bar J. Now substitute the value of J as J plus 1 in one term and minus substitute the value of J in j as it is. So in first case, substitute j is equals to j plus 1. In a second case, j is equals to j. So see here, delta mu bar as it is. Delta mu bar is equals to b. Instead of j, we are filling wherever j is there, j plus 1. So j, that is j plus 1. Now another bracket, j is there, that is j plus 1 plus 1. Instead of j, we are writing j plus 1 plus 1, bracket close. Minus d, instead of j, we are writing j plus 1 whole square. Again, j instead of j, j plus 1 whole square. This one term is completed. Now close the bracket. Now minus sign. So this minus sign as it is. Again a square bracket, d as it is. Now wherever j is there, j as it is. That is the remaining thing as it is. bj into j plus 1 minus dj square j plus 1 whole square. So bracket close. After simplification, this is a big lengthy term, we don't want this much. So after simplification, we get 2b into j plus 1 minus 4d j plus 1 whole cube. If you want, you can try it. You will get the same answer as that of here. That is 2b into j plus 1 minus 4d into j plus 1 whole cube. Now here we will take a 2 into j plus 1 as common. The remaining thing is b minus 2d into j plus 1 whole square. As the value of j is increases, as the value of j increases in this formula, as j increases, the factor b minus 2d into j plus 1 whole square is decreases. Hence delta mu bar is also decreases as the value of j increases. Thank you. Once again students, in a previous equation, that is in a rigid rotor, we got the value of E is equals to h square divided by 8 pi square I into j plus 1. So as we know energy equation, that is E is equals to h mu, we have to take mu, that is we got the value bj into j plus 1 divided by 8 pi square I. If the molecule is behaving like a rigid, then the bond is very short. As the bond or the distance between the two atoms or a molecule goes on increases, then the bond will not be strong. It is going to be weak. Hence this bond is known as a non-rigid. So as we have mu is equals to, that is frequency is equals to bj into j plus 1. In terms of wave number, this can be written as a bj into j plus 1. So now this, and for a non-rigid rotor, this extra term will be added here. So this d is nothing but a centrifugal force, centrifugal constant, distortion constant. So mu bar is equals to bj into j plus 1 minus dj square into j plus 1 whole square. The transition is taking place from j to j plus 1. So the difference between the energy level is given by delta mu bar is equals to delta mu bar j plus 1 minus delta mu j bar. So now in first case we have to substitute instead of j we have to substitute j plus 1, and the second term remaining as it is. After simplification we get this equation. As the value of j increases, this factor will be decreases. As this factor decreases, delta mu bar is also decreases. Thank you.